Hi all, I am from onlineclass4u.com. Today we want to discuss a very important and basic building block of most of the computer programming languages, that is pointers. Most of the beginners always confused with the complexity or syntax of the pointer data type. However, it is not that complex as it sounds. We'll start with a very basic C program to understand the various keywords of the program and then understand the memory organization. Finally, we'll talk about how a data is occupying in the memory architecture and how we need to work with a pointer. This is a demo video created for promotional purpose only. Live classes will be more interactive and in-depth to explain the concept of the pointers. Let's explore this small program with some basic syntax and we'll try to understand the different keywords used in this program, right? So first line of this program, the first line of this program is int x equal to 6, right? And then second line is printf %d and x, right? So basically what we are going to do is there is an integer type data which is x and we are assigning it to 6, right? And in second line we want to print the data. So this will print 6, right? So integer, this is called is a data type, right? So it can be integer or character type or a float data type or double data type, right? Second is the variable name itself, right? The x, this is called identifier, right? The third keyword is a operator. Third is an operator, right? So which is basically assignment operator and it assigned to 6, right? In the second line there is a format specifier, integer type format specifier. In this slide we want to discuss about the memory organization, right? How a compiler accesses the memory, right? For simplicity we are considering one byte-line memory, right? And later we are going to explain a word length memory organization. So let's start with the basic memory allocation in the byte-line, right? So if you see left hand side there are address and there is a memory itself, right? So this is a byte-line, that means every row consists of 1 byte only, that means 8 bit, right? So this is the first row. We are considering it is started from 2000 address, right? Memory location 2000. So next memory location will be 2001. The next memory location will be 2002 and so on, right? So if we do pointer plus 1, if pointer is pointing to 2000, pointer plus 1 will be 2001. Pointer plus 2 will be 2002 and so on. Let's say for example, if pointer is pointing to 2007 and if you do pointer minus 1, then pointer will be pointing to 2006. It's simple arithmetic, right? So now come to the second diagram. So here if you see each row consists of 4 cells, right? That means each memory word is a 4 bytes, right? Or 32 bits, right? Again we are considering the memory is starting from a memory location of 2000, right? Second word, the starting address of second word will be 2004. The next will be 2008 and so on, right? So if PTR is pointing to the first address of this memory, right, the word memory, then second will be pointing to 2004, right? That means PTR plus 1 will be 2004. PTR plus 2, it will be 2008. It is not PTR plus 1 equal to 2001 because when you add pointer, it will be the whole length of the row, each row, right? So this is the memory organization. So if you understand this memory organization clearly, I think pointers will not be a complex for you. It is only the syntax how you are going to write in a program, right? In this slide, let's discuss about the syntax and types of various pointers, right? So what kind of different types of pointers are there? So there are mainly 2 types of pointer. One is the name pointer and another is unnamed pointer or generic pointers, right? but commonly we know this pointer as void pointer. So what are named pointer? Named pointers are like integer pointer, float pointer, double pointer, or any user defined pointer to a structure or any data type, right? So basically, in case of named pointer, we know the type of the pointer which it is pointing to. In case of unknown pointer, we don't know the type, so we can hold the address, generic address of a memory location, right? While storing, I think the memory address is sufficient, right? And when you retrieve the data, we need to know the actual type of the pointer to get the data. Let's discuss about the syntax in C program, right? If you see the first line, it's in star ptr, right? So star is denoted for a pointer. Star can be placed after integer or before the variable name, right? So in C language, star can be placed after the data type or before the variable name. Similarly, float pointer and user defined structure pointer, right? Last one is void pointer, where the data type is not known. So come back to this picture where in the location x is the variable name, 76 is the value, and there is a pointer variable which is pointing to the memory location of x. In this slide, we'll discuss about how a variable is assigned and allocated in a memory table, right? Memory area basically. Right? This table contains 4 cells. That means it is a word aligned, right? Word aligned memory. Each row consists of 32 bits or 4 bytes. The variable x is occupying 4 bytes in the first row, and memory location is 2000. Now in C programming, how I will assign 6 to variable x, right? It's simple, right? Integer x equal to or x assigned to 6. So 6 will be assigned to x now. Now, what is the memory location of 6 or memory location of x? This is 2000. So in C, how I will print the memory location. So there is a operator called ampersand operator, right? Ampersand operator. If you place it in front of any variable and print it, you will get the address of the variable. So the printf of x will be 2000, right? Okay, so far we understood nicely. So now let's consider there is a pointer which is pointing to which is basically sitting on some memory location, right? So this pointer 2024, right? This is a pointer type variable, right? Int star ptr. That means it will allocate a memory of 4 bytes. 4 bytes memory it will allocate, and the variable name ptr will be assigned to 2024. Right? So now you need to link this pointer to the variable x. How? Ptr equal to ampersand of x. So what does that mean actually? So address of x. So ampersand already we know. Ampersand of x means address of x, which is basically 2000. Right? So 2000 is placed in a pointer value. Now you understood? So pointer is occupying 4 bytes memory from location 2024, and value of this pointer, right? Data stored in this pointer is actually a memory location, which is 2000, which is also known as x, variable x, and which contains the value 6. Right? Okay, let's see what printf x will print now. So printf x is actually assigned to 6, right? 6 is assigned to x. So printf of x will be 6. What will be the address of x? So you know address is actually the memory address where x variable is assigned, right? So address of x will be 2000. Right? Now if we execute this printf statement with ptr, so ptr is what actually? Ptr is pointer, right? So ptr is pointer, so it will display 2024. Basically it is address of the pointer type variable, right? So it will give 2024. Now the last example is printf star ptr. So what is this star ptr? So once you put star in front of a pointer type variable, it will dereference. That means it will create the link and will go to the actual memory location. Now star ptr means the value of the pointer type variable. What is the value? Value is actually 2000, which is actually address of some other memory location. Now once you dereference, it will give you 6. Basically this pointer is pointing to a memory where value is 2000. This is the memory location which is in the table 2000, and then it will use 6. So in this slide we'll discuss about the size of operator, how it behaves with different pointers, right? So for simplicity, we'll consider an integer variable, right? The same example where x is assigned to the value 6, right? Okay, and it starts from the memory location 2000. Right? So integer pointer we have declared here, integer pointer, and that this pointer is pointing to a memory location, right? Which is actually x or 2000. Right? Now size of x, right? So what is size of x? X is what? X is an integer. That means size of integer. So in a 32-bit compiler, right, or a word line, memory table, the integer size of integer is 4 bytes. So size of x will be 4, right? That's in byte. Now what will be size of %x? So what is %x now? %x is memory location, which is 2000, right? And this is a value actually. Right? Memory location is a number, and which is 2000, right? 2000. So how many bytes it occupies? It occupies 4 bytes, right? So the value of the output of printf, size of x %x will be 4. Similarly, if we want to print the size of pointer is basically what? 2012 to 4, the address of the pointer itself, right? It is not address of the variable which is pointing to, but it is address of the pointer itself, right? So address of the pointer is 2024. So this is again a number, so it will be, size will be 4, right? So consider the last one, size of pointer. What is size of pointer? Now when we say pointer or we place pointer in front of ptr, it is basically dereferencing the value, link the value, right? The pointer is pointing to 2000, memory location 2000, and 2000 is holding a value of 6. That means it is size of 6. How many bytes it is occupying? It is occupying 4 bytes, right? So size of pointer will be 4, right? Let's take another example to understand the size of operator in C, right? So this time let's consider a character variable which is having a value of a. You see here it is a, and in memory location 2000, right? It's a variable name is character, right? So how we are defining in C? Character ch, and it is assigned to a, right? Basically a is assigned to ch. Now to define a character pointer, we're doing char star ptr and % of ch. That means the memory location of ch, the variable ch, will be assigned to character pointer, right? So which is basically the character pointer itself is having a memory location 2024, and it is holding 2000, right? That is what actually the character % of character, right? And character is holding the character a. So what will be size of character? Everyone knows, it's a 1 byte only, right? So what will be size of % character, right? %ch. So %ch is what? %ch is 2000. This is a number, or this is an integer. So how much memory it takes? How much it, this value occupies? This is 4 byte. So value will be 4. Let's consider another example. It's a printf of size of cptr. What is size of CPTR? Size of CPTR is actually memory address, which is 2024, right? And nothing but it's an integer value, right? What is the size of integer? It will be 4, right? Next, let's consider this example. This is actually print of star PTR. Star PTR. What star PTR means? It is dereferencing the pointer variable, right? So when you dereference, the pointer is holding a memory address 2000, and that memory address is occupying the character A. So that means it is a character, right? So what is size of character then? Here, size of character will be 1.